this is for class 12, that is limits and derivative. Limits and derivative. I again want to clarify you that limits, it is nothing. Suppose here this is a function. Suppose this is a function. This is a graph. Suppose this is a function. Y is equal to fx. Y is equal to fx. So here, let at x is equal to a, you have to find it out that whether the function is continuous or not. So you move from the left side, you are not going very far. You are moving from the left side, and this distance be h. So this point will be x is equal to a minus h, and this will be a plus h. So when you move from the left side, you are almost going to reach at x is equal to a, then your result is fa. And at the same time, if you move from the right side and you are almost going to reach at x is equal to a, and your result is fa, that means at x is equal to a is continuous. This is all. This is a simple theory. Now, if you have to examine, say if you have to examine any function, you have to examine the continuity of any function. You have to examine the continuity of any function if you want to examine. So let the function be, that is fx is equal to x minus f. You have to find the continuity of this. You have to examine. That means examine. It is nothing examine. That means it is a single function. So let us take, we are going to test at x is equal to a. So when you are going to test this x is equal to a, let us take the case 1 where you are taking a value that is a, that means x is equal to a, you are taking a value less than 0. That means less than 0, that means you are taking a value this side less than 0. Any point here, because this is the only function. So because this is the only function, it will be a continuous function. Because there is only one function here. So less than a, this function will be satisfied. So any value less than a, it will be a continuous function. And in the case 2, suppose that we are considering greater than 0. Then greater than 0, that means this side. This is the same function. So it will be continuous at x greater than 0 because there is only a one function. So it will be continuous. And next is that x is equal to a. We will get this, the three result will be the same thing. This is what we have to examine. So you take a case that is a less than 1. Here you are considering this side. So you are considering this side, that means less than a. Some point, that is, let us take some point less than a. You can take a, or you can take c, some point which is less than a. You take some point which is less than a. Any value c. So you will have to test it. That is again the left hand limit, that is limit x tends to c minus, that means fx, that is a limit h tends to 0, that is f c minus h, here. You are taking let us take this value a, because we are taking the value of a, that means we are taking the value of a less than 0. Here we are taking the value of a first case less than 0. Because this is only one function, so it will be continuous. Just you have to show that your left hand limit here. So this will be how much? Limit h tends to 0, a minus h minus 5. So this will be a minus 5. And again your right hand limit, limit x tends to a plus, fx. So here again your limit h tends to 0, h tends to 0, f a plus h. So here your limit h tends to 0, that is a plus h minus 5. Your result is a minus 5. So this side it is the same, it will be continuous. Similarly in this side you are taking the value of a greater than this. That means you are taking here this side, this is the 0 point. So here again you have to test this limit, that is limit. Same thing you have to do, x tends to a minus fx. So here again your limit h tends to 0. So this is f a minus h. So this is limit h tends to 0 and your value is a minus h minus 5. So it comes to be a minus 5. And again your right hand limit. Right hand limit, that is limit x tends to a plus fx, that is equal to limit h tends to 0 f a plus h. So again here your limit h tends to 0, that is a plus h minus 5, that is equal to a minus 5. So this side it will be continuous. You have to just show that you are taking the value of a which is greater than 0 and here you are taking the value of a which is less than 0. And at x is equal to a, here this is at, sorry, this is the point at x is equal to a. This is the point where it is x is equal to a. Where x is equal to a, this is a minus 5. So here you see all these results are the same. So it will be continuous at x is equal to a. This is a natural case because it is a one function. So if you, this is an explanation which has been given in your book just to clarify your doubts. What is the meaning? Examine. That means you have to just, they have made an explanation about it. That we have to consider less than a. This is the same thing if you directly you take limit, that means x tends to a minus, that is fx. That means you take directly you are taking limit h tends to 0 f a minus h. So this will be a minus h minus 5. So this will be a minus 5. Again your right hand limit x tends to a plus, that is fx. Limit your h tends to 0 f a plus h. So this will be here limit h tends to 0. So here this will be limit, that is h tends to 0 a plus h minus 5. Again you are getting the same. You are directly I am testing at a. I am coming from the left side, I am coming from the right side, and for f a it is equal to a minus 5. You can do like this also. There is nothing wrong about it because here a, I am coming from the left side, I am coming from the right side, and it is a one function. So it will, in this less than 0 it will be continuous, greater than 0 it will be continuous. This is an examine, you have to examine. You can examine it like this also. This is all about your limits. Now next, about your derivatives. Here we go about your derivative. So this is differentiate. You differentiate. Let us take an example of a modulus function. Here you see, let us take an differentiable. We are considering here differentiable. Let us consider a function y is equal to modulus x. So what is the graph of modulus x? The graph of modulus x is this and this. So at x is equal to 0, here at 0, the slope less than greater than 0, your slope is this. Your slope, the slope of the graph is this. This is your tan theta, and at less than 0, your slope is this. So your angle is this here. This is the angle here. So this is your tan theta 1. This is your slope, and for greater than 0, this is your slope. These slope are different. So at x is equal to 0, it is not differentiable. It is a single case. But now you have to prove that. So prove you to the here f at x is equal to 0, that is left hand derivative limit h tends to 0 f 0 minus h minus f 0 by h. So here this will be limit h tends to 0, 0 minus h, 0 minus h, and then f0 is 0 by h. So here it comes about limit h tends to 0, that is h by h, and this is equal to 1. This is your left hand derivative, and your right hand derivative, it is limit h tends to 0, f0 plus h minus f0 by h. This is solid, this is minus h for left hand derivative, so answer is minus h, and for right hand derivative it is plus h. So here this comes about limit h tends to 0, here 0 plus h, and this is 0 by h. So here this is limit h tends to 0, h by h. So this is 1. So here your answer is minus 1. So your left hand derivative is not equal to right hand derivative. So it is not differentiable at x is equal to 0. This is all about differentiability and limits. It is a very simple chapter. Do not get confused about limits and derivatives. This is all about for today. Thank you.